Poisson distribution was derived in the year 1837, and this was derived by a French mathematician, Simon de Poisson. He named this distribution after his name as Poisson distribution, and he was in between the age of 1781 and 1840, and he derived in the year of 1837. And this distribution can be also said as the limiting case of binomial probability distribution under some conditions. See, the, there are some conditions. A problem following a binomial distribution, we already discussed regarding that topic. When the number of trials are finite and when there are only two outcomes, that is probability of success and failure. Next, all the trials are independent and success is denoted by P and failure is denoted by Q. If these four conditions are satisfied, then the problem is said to be followed binomial distribution. And when similarly we have some more conditions for a problem to be satisfied, Poisson distribution. In what situation we do use binomial distribution and in which cases we do use Poisson distribution? See, why I told you the word like uh, Poisson distribution is a limiting case of binomial probability distribution. Limiting case means, I'll tell you what is that exactly. Say, let us suppose what are the three conditions they are asking to be satisfied. Here in Poisson distribution, n value, the number of trials is indefinitely large. That is, n tends to infinite. In binomial distribution, it is n is finite. Here in Poisson distribution, n is infinite. The second condition, the value of P, the constant probability of success for each trial is indefinitely small. That is, P is almost equal to 0. Almost equal to 0, but it doesn't mean that always P is 0 here. And the mean in this Poisson distribution is denoted by lambda, and lambda is equal to NP is finite. See, actually the formula of Poisson distribution, is P of x is equal to e power minus lambda into lambda power x by x factorial, where x is ranging from 0 to infinite. This is the probability distribution function, probability function of Poisson distribution. So here lambda is our mean value. Let us take an example. I'll just try to differentiate what is an example of Poisson distribution. When to take a Poisson distribution and why it is called as limiting case of binomial distribution. Now, in binomial distribution, how many outcomes are there? There are only two outcomes are there. Okay, the probability is how much then? It is 1 by 2. That is equal to almost equal to 50%. Yes or no? That means probability of success. That means always we have seen a situation. We have seen tossing of a coin. So it is 1 by 2 and 1 by 2. So our probability of success is 50%. Since there are finite number of trials are there. That means let's take an example of 10 trials are there. Then what happens? 10 times we try to find out whether we have got head or tail, that is success or failure. Every time we used to find out the same kind of thing. That means if we have only two outcomes are there and the number of trials are finite. Now let us suppose if there are 10 trials are there, then the probability of getting success, that means probability of selection of one person. Let us suppose there are only two people in the class are there. What is the probability of selecting each person? It is 1 by 2. If suppose there are 10 students in the class, then what is the probability of selecting each person? That is 1 by 10. That means my answer would be 0.10. And next case, let us suppose we have 100 students are there. 100 students are there. Then what is the probability of selection of each member? That is probability of getting each person is 1 by 100. That means what? Again 0. What do we get? 0.01. It's not 1 point, it's 0.01. 0.01. The probability of selection of one person out of 100. Similarly, if I want to select one person out of 1000 people, then what is the probability of getting him? It is 1 by 1000. That means 0.001. Similarly, if the number of students in the class are 10,000, number of students in the class are 10,000, then the probability of selection of each person is 1 by 10,000. That means it is 0.000 one. Let's take an example of these values. Now see here what it is being happening over here. See, number of trials 2, 10, 100, 1000, 10,000. That means if the number of trials are increasing, then the probability of getting success. See here, first it was 50%, next it was 10%, next it is 1%, it is 0.1%, it is 0.001%. That means if the number of trials are increasing, instead of tossing of 10 coins, I am tossing 9,000 coins or 10,000 coins. Then what is the probability of getting one head only? Out of 9,000 times, see, it is not only the case of that one. I am just taking an example. Now, if the number of students are increasing here, the probability of selecting the same person is being decreased. I want to be select you only from your class. When you are 10 people, it is only 10%. It was 10% chance for you to be selected. If you are out of 100 people, it is 1%. If you are in 1,000 people, it is 0.1 percentage. That means if the number of trials are increasing, then the probability of success always decreases. And see this 0.0001 means almost equal to 0, but exactly that is not equal to 0. And here, if I take next case, if I'll take instead of 10,000, I'll take 1 lakh. Then what happens? The probability of selecting one person becomes 1 by 1 lakh. That means again 0.1234, 4 zeros and 1. That means indefinitely the number of trials are increasing. See this case. The number of trials is indefinitely large. That means almost n is equal to infinite, uncountable set of values. Then my probability of success will be almost nearly equal to 0. See, almost it is near to 0. In these two cases, but though you multiply n into p, what is n into p here? Mean. Mean of Poisson distribution is lambda, that is n into p. Infinite doesn't mean that doesn't have a value. It is having a value, and your p, probability of success. Now, number of trials are how many? Lakh into the probability of success. The probability of success. Let's take this only. Let's take this example only. Into the same thing. Then what do you get? Almost mean is equal to 1, right? Lambda value is equal to 1. Since the denominator and the numerator value gets cancelled and the remaining value is only 1. So that means when a problem satisfies these three conditions, that means the number of trials should be more and the probability of getting success should be very less. In that particular situation, a problem is said to be a Poisson distribution problem. And why did I tell you the word like it is a limiting case of binomial distribution? Limiting case is nothing but when it is going to be extended. See, when I say an example that when 10 coins are tossed, then immediately you might be asked me that, sir, why only 10 coins? Why can't we take 100? The another person might say that. That means if the people are trying to increase the values, that means if it is extending, if you are dragging towards the right hand side, then it is going to be change its characteristics. Then it is going to be changing its characteristics like these percentages. So then complete model gets changed. Complete model gets changed. Now, there are some situations that means number of trials will be very high and the probability of getting success is very low. What is that situations? When what type of problems, what type of situations follow Poisson distribution? Is that, let us see here, number of mistypes in a textbook. Number of mistypes means, see, there is a textbook consisting of n number of words, uncountable set of number of words. Per page itself, we can find out hundreds of words. Out of which, do we find any mistakes in a textbook? Not all the time. It's a very rare case. Out of a complete textbook, you find one or two mistakes in the textbook, or at least that also will not be there. That means number of words in the textbook is my number of trials. That means the count of the numbers is very high here, but the probability of getting mistypes is very less. Next one, number of defects in a manufacturing product. Let us suppose there is a manufacturing company manufacturing whatever it might be, biscuits or bikes or whatever it might be. Out of 100 bikes or 1000 bikes or 10,000 bikes, how many number of bikes might be defective? Either one or two, right? That means my success is only one. I'm asking what? Defective. So defective is my success, and the other one is perfect article. Perfect is article is not my cup of coffee, right? Next one, number of suicides reported on a particular day. On a particular day. On a particular day, n number of people are expiring due to different cases, whether it might be heart attack, accident, whatever it might be, out of which intentionally how many number of people are getting died by using suicide? It is also a less number. And one more case is like number of accidents occurred on a busy road. Let's take an highway. On a highway, per minute, hundreds of vehicles will be moving with a speed of 80 to 100. On that busy particular road, let's take an example between one toll gate to the another one. There are hundreds of vehicles are moving per minute. So in this number of vehicles, how many number of accidents can occur? Accidents may occur, may not occur. Though it happens only one or two, not 10 or 20 on a busy road all the day, right? So that means number of trials will be very high, out of which getting my probability of success will be very low. Then that case is called as Poisson distribution. And out of all these examples, see here, mistypes, defects, suicides, accidents. All these words are a negative kind of words. Suicide is a negative kind of word, accidents, mistypes, defectives, or negative words. That means if it's a symbolical way how we try to remember a problem that belongs to a probability function of, so it's belong to a Poisson distribution. If you find out any such negative words, that problem belongs to the Poisson distribution most of the times. Okay, not all the time, most of the times. And here, see here, the formula is e power minus lambda into lambda power x by x factorial, where x is ranging from 0 to infinite. Here, there is no higher range here. There is no, the value, the number of successes cannot be up to n. It is uncountable set of values. So I cannot write it as n value here. Okay. So what is the difference between binomial distribution and Poisson distribution here? In binomial distribution, the x is ranging from 0 to n. But in Poisson distribution, x is ranging from 0 to infinite. 0 to infinite. Okay, so the expression of binomial distribution is called as Poisson distribution. That means again a difficult problem belongs to a binomial distribution. Even in that also extra more difficult problem, if the problem is getting more and more complicated than the previous problems, then that is said to be followed Poisson distribution. We use the second model called as Poisson distribution. So here, and there is one more thing what we need to remember here is, in Poisson distribution, always mean and variances are equal. In binomial distribution, mean is greater than variance, but in Poisson distribution, mean and variance are equal.